So thank you, and hello. This is Björn, this is Dan, and my name is Daniel, and we've built an app here in Plymouth called Let's Combine.
Yeah, so I think we can see the web page right here. We'll just start with the live demos because we have a lot of devices. So on the website you can choose a location in the UK and then just get some interesting open data results. So I'll pick Leeds right here. We'll see a loading screen and I hope it works. Yeah, so we can see there are a few Sherlock Holmes views, and that obviously results in good broadband internet because the connection is not being slowed down by them. And we just picked different data sets because we couldn't really decide if we just want to pick one of them. So we decided on a project that uses multiple open data sets and combines them into those cards that just show funny and interesting results. And we also plan to add in more and more data sets later on. So for example, yesterday we added in the Sherlock Holmes viewers, and it's easy to add in more and more data sets. So those cards are generated dynamically on a server and can be displayed either in this AngularJS web page or also on multiple mobile devices, as we will show you now. So yeah, that's kind of a little bit bad, but we'll show it to the jury afterwards. So
this is our iOS application, which I made. First of all, you get a screen to select the categories you want to choose from. Apparently someone likes this up there. So if you tap Show Information, you get all the same cards based on your current location. So this is the data that's available here in Plymouth, for example. If you tap Show Information and you tap on one of these cards, you can share them because there's some quite funny things sometimes. The map allows you to choose a different location as well, so you can do the same thing that we just showed on the website. So that's the iOS app.
So we also got an Android phone app. Let me unlock it. So here it is. Can you please show it? Okay, so do you want to?
Okay, this is our Android app. It's almost the same as the website or the iOS version, so geolocation all integrated, and you can see right here the topics.
Okay.
Now the topics, if you don't want to see the weather in your results, just swipe it away. And here, if you have all, just click Show Information, and you get the cards. So we have the last device is the Wear.
Yeah, so we got an Android Wear smartwatch because at IDA they apparently had one, so we just asked them if we can use it. And thankfully they agreed, so we got also an Android Wear app running on the Samsung Galaxy Gear Live. And it basically just shows the same cards, so maybe you can just go down to the judges and show them. And on the smartwatch it was kind of difficult to get it all set up because the API is very new, and on Stack Overflow we couldn't find much help, and also all the mentors couldn't really help us, even though they had some Android experience. So we kind of had to rely on ourselves to get it working.
So here's a quick overview of our technologies that we use. The server is running on Node.js, mainly done by Leander. Our Android guy was Björn. He's made the Android app and the Android Wear app using Java. I created the iOS app in native Objective-C, and the frontend is created using AngularJS. You can download the Android app on Google Play right now. It should work using this QR code. Maybe. But for now, thank you very much for listening, and we'll take some questions.
Yes. YRS Berlin was last year. It's amazing. And again later this year. Questions for judges? Yes.
I have a question. So what's the logic you're using to create these cards?
We kind of integrated a system that just narrows all the information down to a number from 1 to 5. so that we can generate our sentences based off of the data we get. And then we have some cards that can be only, some information that can be only used as a source. For example, it doesn't really make sense to have the weather as a result. So we can say, for example, bad weather results in whatever, but not something else results in bad weather. So we got an algorithm there on the server that meshes them together.
Any other questions? Judges?
What do you see being the main application for this, or do you see multiple applications?
Excuse me?
What do you see as the main application for this? Is it just curiosity, or what kind of thing do you want to try with?
I think it's because all the open data are not really that interesting to look at, so we wanted to find a way to make it a little bit more fun and engaging to explore open data in different cities and different parts of the country.
How do you categorize the value of the information and indeed the level of interest for different groups of people?
Could you repeat that?
How do you categorize the value of the information or interest in different groups of people? What determines what information you put up there?
Yeah, so we have different categories for all the information, but we basically those categories we have on the devices here, which you can choose and decide if you want to see them, are basically just the data sources we have, and we picked some of the data to display. So, for example, we got a lot of data about crime, and then we, as you could see, we had unfriendly people, I think, and it was violent crime. So, unfriendly people is basically antisocial behavior in the police.uk API.
Did you have a lot of difficulty getting the apps, the different platforms to talk to your central server?
Basically, that was very straightforward because we based it all on one central API. So the website uses the same data, for example, as the Android Watch app.
Yeah, the only thing was, as I said, the Android Wear was really hard to implement because there was not that much documentation. It was a really new device, so we had to experiment with that. But other than that, it was quite straightforward.
And what sort of API did you use?
We built a JSON API, very simple, just describing where the information comes from, then the sentence in the card, and what it results in. So where pictures can be displayed.
Lovely, thank you very much.
Hi, I'm Al, this is Nathan and this is James, and we're ProjectThoth. So we, as a nation, have a problem. That problem is word crimes. We envisage ProjectThoth as the next step in eradicating this problem once and for all.
So ProjectThoth is a Firefox plugin, and when you enable it, it sends the HTML page that you're viewing to our web server, which corrects grammatical and spelling mistakes in the plain text before sending it back to be viewed in your web browser.
So we're going to run a demonstration now. James is doing here. So here you can see we've done a demo website with grammatical errors, unnecessary extra exclamation marks and things. So in the top right hand corner, it's our Firefox plugin. You click it to activate it and it turns on. And then once you refresh the page, everything goes well. All the errors are fixed. Do a web page without errors? So these are the technologies that we've used. Nathan has written a JavaScript Firefox plugin which intercepts the HTML traveling to a web page and sends it off to a C# web server, which he also wrote. This then calls a number of Python scripts which James and I have written, which do quite a few things, including correcting poor spelling. This uses a piece of statistics called Bayesian, which I've explained in the comments in the code that is what we're spelling now. So we can do things like abbreviations, so the letter U to the word U, or things like LOL or BRB. And we can also fix capitalization, such as when you have too many capital letters or too few in new things.
So the most important source of open data that we used in our projects was probably the Scout Dictionary, which contains about 600,000 English words and names, and we can use this to identify proper nouns, decapitalising, and we also used several books from Project Gutenberg, which were copyright free, and this was how we trained our spell checker.
So, as a big project, there's obviously things we'd like to take this further with. So if we had more advanced natural language processing, it allows us to add more complex grammar rules, such as the difference between the different versions of your. We'd like to add a Chrome plugin as well to reach a wider audience. We could add whitelisting and blacklisting, so certain websites don't automatically use ProjectThoth. And if we could get an SSL certificate, it would allow us to encrypt our transmissions to the web server and let us use ProjectThoth on HTTPS websites.
So this is something that's just come up in the past 24 hours. We've started talks with a professor of marketing at Oxford Brookes University who is doing data analysis, or they're mining data from Twitter feeds to try and do work out what customers want. But the problem is their miner can't actually handle words which it doesn't know. It can't handle normal Twitter language. And they've asked us if we can help them using ProjectThoth in order to automate the conversion of sort of text speak into proper English.
So, thank you very much. Do the judges have any questions?
Yeah, I think you might have just answered it. I was going to ask what you think the business value of this is versus a standard spell checker.
So this does quite a bit of spell check stuff, it sort of allows it. But the point is, it does it on the website. It does any website if you have an if you can use HTTPS, when you have an SSL certificate, and we can basically translate or filter any HTML name of the website, which is virtually every website out there.
I mean, it's great. You created Google Translate for those people who can't use grammar or spell. Thank you.
Any more questions from judges?
I have one question. So what happens if it comes across a word that's not English?
At the moment, it will probably try to spell check it, and it will probably fail if it's two different English words. That is a problem, though we could also, for certain parts of it, we could quite easily flip to use another language. So the spell checker, you just have to feed it with books from another language, and you'd have to find a similar thing to the Scout Dictionary for other languages, and it could run.
Any more questions from judges? No? Brilliant. All right, thank you.
Thank you very much.
This is an app that we created together, and we thought there was a problem where several years ago.
Okay, so imagine now you're in a new city and you don't know what to do. So you spend a while hassling with your guidebooks and then maybe TripAdvisor, but then you've got the extra problem about when you're out and about, you have to use your phone for mobile data, and that's going to cost you a lot. And we thought this was a real problem. And yes, you can use real physical tour guides. This is expensive and it's not customized. It's going to be the same for everyone. So we thought we found the solution to the gap in the marketplace with our app, Tourify.
So yeah, the solution is Tourify. Want to just get out, when you get out of the plane and you just want to see the city as soon as you can, you'll be able to do that with this app. It has up-to-date reviews and you'll be able to customize your tour completely depending on what you want to do and what the weather is like. I'll get into that in a bit later.
So unlike guidebooks, it's constantly updated, so you're always in the know with the latest reviews. Unlike TripAdvisor, we provide all the information you need. So for example, TripAdvisor won't tell you if it's going to be raining when you go there. And so you might want to go to a beautiful park and then find out it's raining. We're not going to show you that because we know that's not useful. And thirdly, physical tours. They're much more expensive, while our app is free, and these work anywhere, wherever you are.
The bit of the implementation that I was involved in was trying to solve the travelling salesman problem, which I'm sure a lot of you know is a notoriously difficult thing to solve. It uses polynomial time basically, which means, for those of you that don't know, the more as something increases, in our case the amount of places to go to, the time that it takes to process that data will kind of increase exponentially. But we realised that we've got a cap on kind of how many things that someone can see in a day. So for this, the best method was brute force to use, because, however, if we have more things, we could use something along the lines of Dijkstra's algorithm and then getting back to the point. But the travelling salesman problem, basically what it is, it's finding the quickest route, starting at one point, going to a selected number of points and getting back to that same point. So for example, yesterday, me and Gerard actually went on a tour to test the app for the first time around Plymouth. I've never been to Plymouth before. We started at Plymouth University and went around. We went to Plymouth Cathedral, the Museum and Art Gallery, and the Central Park, and it found us the quickest route that started and finished at the Plymouth University. So what we got to keep the API requests down. So how we do that is we use a have-assigned formula instead of Google distance matrices at first. So it's basically, I've learned a lot because I knew nothing about geography or any of this. So it's just really fun maths, for those of you who love maths like me. Basically finds the distance between 2 points on a sphere and uses that to then implement it. It's quite a complex algorithm, but that's how it does it.
Alright, so here are the APIs we use and how everything works behind the app. So we actually have a web app and an Android app. This is a picture of the Android app, which I'll show you in a second. So we use GPS to find your longitude and latitude. That's converted into a location. And then that goes to a Heroku server, which then returns all these different bits of APIs. And these are just some of them on the screen at the moment. So, should we get into the demos?
Yes. Yep. So, thank you all. We'd like to thank especially Chris, Ollie, people that helped us at SwiftKey Centre that we were working at, and Andy as well, I forgot to mention on there. Everybody here at YRS for helping out organising it, and of course all of you for coming and watching and being involved and making this event great for all of us, I think.
Okay, so here's the demo of the web app. We decided to make a web app because it's multi-platform, and we also made it a custom responsive design, which we made from the ground up, so it also works on iPhones. We realised we had a gap in our skills, but we worked around it by using the HTML5 latest API. So you're on the website, you can click this, and then click allow to get the location.
Find your location.
You can either click start tour or customize. Custom tour. So we wanted to see different things. So maybe you can change other things, like if you want to go by bike or things, and you can change if you don't want to go to a zoo, for example.
The clicking is quite difficult.
But anyway, so finally you click start tour, and it loads all the results up.
And then you can delete results if you don't want to use them. And then finally, okay, here we go. You can just press finalize, and then, as you said, we're using that algorithm to find the shortest route, and it's got turn-by-turn directions. We've also got an Android app that I'll quickly show you very quickly. So I've just got I'll just get the screen up where you'll see all the different places where you can go to. It doesn't seem to be working at the moment, but first one that's not working anyway. But yeah, there is an Android app that works, and we're still developing it. But yeah, your web app will be available to be used just after this. So I think that's pretty much everything. So thanks, and we'll free.
And Gerard's down there, and he's going to show the judges the web app. Because the great thing about the web app is it is multi-platform. So even if, unfortunately, your app is down at the moment, you can still use it on iOS or Android or anything like that.
And whilst you view the web app, we'll be happy to take any questions if you have them.
get it one?
Not right now.
Not right now, no.
Yeah, but yeah.
Are there any questions from the judges, or are you still looking at the app?
You mentioned very briefly that it will eliminate results that aren't appropriate because of weather. Are there other factors that you've taken into account?
Yeah, we've got loads.
So we check if it's open, because it's no good if it's closed. Weather, so it's going to be not raining. And then we filter out things that got bad reviews, and we take things that are only relatively close. So you're not going ridiculous distances to get to what you need to do.
Right. So you've dissolved the user interface for a lot of that stuff. So it's making intelligent choices. That's really cool.
Yeah, so the whole point is, as you can see, the slogan, it's not up at the moment, but our slogan's "You're unique and tour unique." It's basically saying that each tourist is unique, so should their tour be. So that's kind of the motto we have.
Will it randomize so that the next time you hit start tour, give you a completely different set of results?
We can add that, I guess. We've been very rushed to try and finish it because it's a lot of features to bunch into one thing, especially with all the different APIs we're using. But yeah, that's a great idea. We'll add that.
Do you have special categories for things like of interest to children, disabled access, tolls, prices, that sort of thing?
As of yet, we've only added a few custom features because due to time limits. Although in the future, we definitely like to expand to make it more appropriate to other markets such as children, families, and things like that. So it's a great idea. We'll add that soon.
So one of the screens I skipped over to has me crossing a body of water. Considering you said you chose walking directions only, how do you propose to get me across?
Oh gosh. So it's taking you across the body of water and you're still walking. I think that's probably a bug in the software there, but
there might be a bridge. We're not sure.
There was a bridge.
No, it's not going.
We're sorry about that.
I don't know how to swim, so...
Can't you swim?
Alright, thank you very much.
We're Team FlappyWorks, and our project's named Intersection. So, what is it? Well, we built a multiplayer tower defense game. So most people here will have played tower defense. It's a great simple idea, but it's been done so much that it's got stale. So we built it in multiplayer with both players acting in a different role, synchronized it across the browsers, and we based it on real-world data to create stages. So it's played on a map, and it uses real police data.
So, what does it use? Well, Intersection makes use of HTML5, CSS3 and Bootstrap to create a responsive user interface that will work on any platform. The client side uses jQuery and Rewired.js to load in the data and everything else, of course, to run the game. And everything is synchronized with the WebSockets wrapper Firebase.io.
So, how do we do it? Well, we tried to follow best practices where we could. We designed UI through sort of wireframing. We followed a Kanban board to divide up the tasks between everyone, and we learned to use Git, which none of us had done before. First day we were just pushing everything into master and stepping on each other's toes. By Thursday we were loving it, everything was in a separate pull request.
So now I'm going to do a quick demo. So imagine these two browser windows are separate computers from different people. So if I were to set a nickname, boss. Now it's going to open the lobby. Now there is a session open, but I want to create my own session here. So this is... now I'm going to sign in here with... Okay, so someone else has joined my session. However, I can begin my game, even so, and if I choose attack mode, then I can begin the game, and that should have appeared on their screen. It would have been helpful if they hadn't joined my session. However, I can still add units, and those will appear on his screen. So I can add tanks, heavy artillery, things like that. Whoever has connected, please place a turret in the blue area. Unless you want me to do another one.
Do it again.
I'm going to reload. Okay, you've placed a turret. Thanks for that. Now, if I don't do too many, please, if I move this soldier towards the turret, it will probably be annihilated as cannon fodder because the turret is much stronger than the soldier. If I zoom in, that's Covent Garden they place it in. Now if I place my, look, see, he's attacking, or that one did just now. However, my soldier did do some damage to that turret, but he's sort of annihilating my soldier. However, I can bring in the heavy guns and the tanks as well, so if I move this further in.
And we are limited by the real police force budget for London.
Yeah, these red areas. The balance you see here, every time you have a soldier, say, this is going to reduce my balance a little bit. And that balance comes from, the budget data we pull in from elsewhere. And these red areas all represent the crime rates, which are obviously very high in central London.
So but there's a really big crime rate. The attacking side gets an attack bonus.
Now that wasn't me that added that tank. That's okay. That's a defending artillery. I didn't add that. However, if I move towards him, it will probably. Okay, well, I think that sums it up. So if I wait, whoever connected, please close your browser window, and it should say. Okay, well, you're not closing your browser window, so I'm going to close mine. Okay, thanks for this. Now I'll go back to the future.
So, the future. Where do we go from here? The responsive design means that we can continue to optimize it and make it work on many different devices. It would be great to see it on a console or some other platform like that. It would be also great to bring in more than 2 players, make it a MMO, say, and let thousands of people, or just friends, join together and work on their own map, fighting each other. And it would be great to make use of more data, obviously, such as traffic data to slow down speed up units based upon the current congestion of an area. Thank you.
If you like, you can always show it to judges later if they want to see.
Could you just run a bit more detail on the data sources you used?
Well, the main data sources we used were obviously Google Maps to provide the map interface. We used data.police.gov for the statistics about the crime rate, which we then converted and made it into a nice format for the system to use. And we also used other online sources for the police budget for particular areas.
Any other questions from judges? No? Bill? No? Thank you, guys.